Okay, today we are going to be looking at just word problems. We're looking at different kinds of word problems.
Right, Pastor, your lunch is here.
And now Mr. Pastor gets to eat lunch. We'll be looking at different kinds of word problems, and we'll be bouncing back and forth between the lesson on greatest common factor and on least common multiple. So be ready to move back and forth between some pages. The first thing that we're going to do is we're going to look at example 4 on page 33. This is the greatest common factor. So remember, these are going to be numbers that are smaller than normally it's their numbers. Greatest common factor is going to be a number that's smaller than any of the options that you're looking at, any of your target numbers. So in this first example that we're going to look at, you are filling piñatas for your sister's birthday party. The list shows the gifts you're putting into the piñatas. Looks like you have 18 bottles of nail polish, 24 pairs of earrings, and 42 lollipops. You want identical groups of gifts in each piñata with no gifts left over, because you don't want anybody complaining and saying they didn't get their fair share. So what is the greatest number of piñatas that you can make? The greatest common factor of the number of gifts represents the greatest number of identical groups of gifts you could make. So when a problem asks for something like, what is the greatest number of piñatas that you can make? That's what you're going to look for. You're going to look right here. What's the greatest number of piñatas or bouquets or arrangements or whatever? That's always going to be the greatest common factor. And in this book, it has you using factor trees to show that out, or prime factorization to show that. So they wrote down the prime factorization for 18, 24, and 42. If you're not sure how to find the prime factorization, there's another example that's right over on page 32. Right next to it, it was example 2. And also lesson 1.4 was all prime factorization. So once you find all of the prime factorizations, you find the common prime numbers between all of them, and that is 2 and 3. You multiply those together, 6. The greatest common factor of 18, 24, and 42 is 6. So you can make 6 piñatas. I know some of you guys like to list factors instead. So here's the same work. This is my notes for page, or for the word problems, just the word problems part. Here are my notes. This is the same problem on page 33 using factor lists. So you see, I started going through and I'm like, okay, what are factors that everything has in common? They all have 1s in common. 18, 24, and 42 have a 2 as a factor. They all have a 3 as a factor. They don't have 4s. They have 6s. They don't have any 7s. They don't have any 8s, 9s. Nobody else has a 14 or 12 or 20. There's no other common factors. That's it. So the greatest number that I circled is 6. So my GCF, no matter how I find it, is 6. Oops. I don't know if you saw that. My greatest common factor was 6. We're going to go ahead and do the on your own. That's on page 33, number 8. So if you look at the directions, this. I'm all slanty. Sorry, guys. Sorry, I'm just trying to make this better so you can see it and that makes sense to you. I'm having camera issues. Oh, there we go. Okay. In example 4, which is the one that we just did, if we had 6 more pairs of earrings, does this change your answer? And then you have to explain your reasoning. So remember, we started off with 24 earrings. We're going to add 6 to that, so that'll be 30. So now we have 18 jars of nail polish, 30 earrings, and 42 lollipops. And what I want you to do is go ahead and list, or you can do it either way. You can either list your factors, or you can use prime factorization to see if it's going to change the number of earrings that you had. Go ahead and pause it, try it out, and then resume. All right, so on your own, page 33, number 8, you have 6 more pairs of earrings, which means you have 30 pairs. Here is my 3 target numbers that I have to find, 18, 30, and 42. And looking for my greatest common factor, again, I have all these 1s in common, all these 2s in common, these 3s are in common, and again, I have 6s in common. 30 was the only number that I changed, and I don't have 9s or 18s, anything else in common. So my greatest common factor is still 6. It does not change my answer. But it will change how many pairs of earrings I get. So here I get 1, 2, 3, 4. 1, 2, 3, 4, 5 pairs of earrings, and here I only got not that many pairs of earrings. So I'll get more. I'll get an extra pair of earrings. It does not change my answer, and that's why. All right. Next, I'm going to go ahead and we are jumping pages. So look at page 39. That means you got to flip your pages a little bit. We're going to look on page 39. Oops. 2. Oh, there it is. Sorry. Okay. And again, we're going to look at example 4. A traffic light changes every 30 seconds, and another traffic light changes every 40 seconds. Oh, man. This is totally touching my heart on how often these traffic lights line up, and you just get to go through 2 of them at the same time. When you hit the greens, it's nice. Both lights just changed. After how many minutes will both lights change at the same time again? So keywords at the same time, when will they be doing, when is this same event going to happen again at the same interval, okay? So you're looking for the least common multiple. And the book used the least common multiples. They found that by listing your multiples of 30 and 40. Here I have 30, 60, 90, 120. If I kept going, I'd hit 150, then 180. And your multiples just keep going on and on and on. Multiples of 40, so you're counting by 4s and adding a 0 on the end. So 40, 80, 120, 160, and you see that 120 are the same. That's our least common multiple. That's the first number that you run into that is the same. So the least common multiple is 120, which means that the lights will change again after 120 seconds. That's not what the question asks you, though. It asks you after how many minutes will both lights change. So there's 60 seconds in a minute, and 120 seconds equals 2 minutes. So that's where it gets you get that answer. Now I also did the same problem using prime factorization. I know some of you guys like that, so I switched it around. The book uses lists. I'm going to use prime factorization here for an extra example. So remember, you find the prime factorization of both of your numbers. I write them back down. 2, 3, and 5 are my prime factorization of 30. 40, it's 2 times 2 times 2 times 5. And then you find all the factors that appear and use them wherever they show up the most. So I have 1, 2 here, but I have 3 2s down here, so I'm going to use these 3 2s. And then I have 1, 3, and 1, 5 here, and 1, 5 here. It doesn't matter which one of those I use, I just have to use one of them. So 2 times 2 times 2 times 3 times 5. And you multiply all that together, and it still equals 120 seconds. Oops, can't see that again. 120 seconds, which equals 2 minutes. So your LCM is the same. We are going to look at the on your own number 10 on bottom of page 39. So what if, in this example, the traffic light that changes every 40 seconds is changed to every 45 seconds. Then how often is it going to be, how long do you have to wait until they are changing at the same time? So go ahead and pause the video. Use list or use prime factorization. Either way, you're going to get to the same number. I would use list because this list is right there, and then you only have to do list for 45, but that's me. I'm going to pause it and then come back. Okay, so I listed my 30-second, 30, 60, 90, 120. This is one stoplight, and then the other stoplight changes every 45 seconds. 45 times 1 is 45. 45 times 2 is 90. So then they're both changing every 90 seconds. They'll be the same, which is every 1 minute and 30 seconds, or 1.5 minutes. Your LCM is this 90, but the answer to the question is how often, how many minutes will it be? It'll be every 1 minute and 30 seconds, or a minute and a half. Okay? Now, for your homework. Your homework's a little weird because you're kind of dotting back and forth between assignments. The word problems are all in the Edulastic attachment that's attached to this video. All of those problems come from your Big Ideas math book. But I don't want to tell you which ones they are. If you want to go back to your textbook and figure it out, that would be amazing. But what I really want you to do is I want you to try using the Edulastic problems. It's not a test, it's just your homework. I'll grade it like I normally do. But I want you to try using that, so if you can tell, if you know when to find greatest common factor and when to use least common multiple to answer your story problems. You'll still get 10 points if you fill out the Edulastic paper and attach a picture of your work. You'll still only get 8 points if all you do is answer the questions in Edulastic, but you don't attach a picture of your work. So the grading part is the same. I just set it up a little bit different to see if this is more helpful. I'm looking for feedback from you, which format you like better, if it's Edulastic or if it's the Google form. Okay, let me know what questions you have. Thanks.